Okay, this is Geometry Honors, Section 5.3. These are the video notes for today. So for this section, we're looking at congruent angles associated with parallel lines. So 5.2, we are trying to prove lines parallel. This time we know lines are parallel. So let's just review the previous section. We looked at all the ways to prove two lines were parallel. So if alternate interior angles, alternate exterior angles, or corresponding angles are congruent, then we can prove the lines are parallel. Or if interior angles on same side of transversal, or exterior angles on same side of transversal are supplementary, then the lines are parallel. So basically we have 5 different ways that we can prove lines are parallel. So if we look at the converse of this, it's going to give us a whole bunch of ways to get angles congruent or supplementary if we are starting with the lines parallel. So in this section we know the lines are parallel already, and we're going to summarize this section with one statement here. If two parallel lines are cut by a transversal, then any pair of angles that we could pick are either going to be congruent or supplementary. Now, some of these pairs may not be the special types that we've been talking about with regard to two lines cut by a transversal. For example, they could be vertical angles, in which case we know they're congruent because vertical angles are congruent, or they could be adjacent angles, and we know that if two angles form a straight angle, they're supplementary. But basically any two angles that you could pick, they're going to be either congruent or supplementary. So parallel lines is going to give us alternate interior angles congruent, alternate exterior angles congruent, or corresponding angles congruent. And then for the supplementary ones, parallel lines are going to give us interior angles on same side supplementary, same side of the transversal, or exterior angles on same side supplementary. Okay, so if we've got two parallel lines and they're cut by a transversal, then we know a lot of information. Next theorem, in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So let's draw a picture. Again, this is very similar to one of our theorems from the last section, except we're kind of going in reverse. So here's line M, here's line N. We'll call this line L. So if a line is perpendicular to one of two parallel lines, so we would be given M is parallel to N, and we would be given that L is perpendicular to M. Using this theorem, we can conclude that L is also perpendicular to N. If it's perpendicular to one of two parallel lines, it's perpendicular to the other. Alright, as always, make sure you ask questions if you have them next time you see me. If two lines are parallel to the same line, then they are parallel to each other. This is called the transitive property of parallel lines. And since there's only one form of this transitive property, you can write transitive property of parallel lines, M and L. So given M is parallel to N and N is parallel to L, we can conclude that M is parallel to L. So basically, if they're parallel to the same, so you can see here they're parallel to N, so they're parallel to each other. And our postulate to end the notes, through a point not on a given line. So here's our given line. Here's a point not on the line. There is exactly one line through the point that is parallel to the line. So there's only one line I can draw through this point that would be parallel to this line. So I could draw it here, and this would be the one single unique line going through that point not on the line that's parallel to the given line. Incidentally, if we take this off of a plane and we put it on a different surface, say the surface of a sphere, these rules are going to change. So that would be non-Euclidean geometry, and we won't really study that. We may talk about it from time to time. So if you have any questions, make sure you ask, and that's it for today.